This is problem number 6. Please note that in problem number 5, the answer I put on there was incorrect. It should have been 39.07, which is what I showed you in the last movie. So it'll be 39.07. Okay, now number 6. All right, and number 6, this is the lab where we heated the bolt. The bolt's sitting in the water. Are sitting in the Bunsen burner flame. We're trying to find the temperature of the Bunsen burner flame. To find the mass, we're going to go ahead and fill in the blanks first. So this would be 142. I got that by subtracting those two numbers. Then if I do the subtraction on those, it'd be 53.1 minus 23. Whoops, I'll take that back. It's 53.5 minus 23.1. So our temperature change there would be 30.4 degrees. 53.5, yeah. 30.4 degrees C. All right, we know that we can find the heat gained by the water is equal to the mass of the water times the specific heat capacity of the water times the change of temperature of the water. We know the mass of the water is 142. This is the water that got warmer when we put that really hot bolt in it. Specific heat capacity of the water, 4.18 joules per gram degree C. And the change in temperature of the water was 30.4 degrees C. All right, multiplying those all together, I'm going to multiply together and round to the nearest whole number for simplicity's sake. So 142 times 4.18 times 30.4. It's going to be a pretty big number. 18,044. So that's 18,044, and that's joules. The basic premise of this lab is Q equals Q, where Q of the water is equal to Q of the bolt. So now we could say that Q of the bolt is equal to the mass of the bolt times the heat capacity of the bolt, specific heat capacity of the bolt, times the change of temperature of the bolt. We know Q, 18,044 joules. The mass we know is 48.76. I'm going to leave units off for simplicity's sake here. 0.449 is the specific heat capacity of the metal. It's given to us right here. Delta T we don't know. To solve for delta T, we have to multiply this number times this number and then divide it into that number. So 18,044 divided by both of these numbers. So I'm going to go ahead and do that. 18,044 divided by 48.76. The mass of the bolt's what that was, divided by 0.449. Final answer is 824. So the change in temperature, delta T, is equal to 824 degrees C. But remember, the bolt was hanging in the flame. So the change in temperature of the bolt would be the initial temperature of the bolt minus the final temperature of the bolt. Or, if I add T final to both sides, Ti is equal to delta T plus the T final. And take that up here. So delta T was 824. T final is the final temperature of the water. And so that would be, from right over here, it'd be 53.5. So I'm going to add to that. Whoops. Add those two together, so 824 plus 53.5 is 877.68 or 878 degrees C. And that would be the temperature of the flame. All right, end of that movie.